we have been discussing on the work done by the force. In a couple of previous classes, we saw how a constant force acting on an object can do some work, and based on that we have done a couple of conceptual problems. Now, the situation could be where the force acting on the object is a variable force. So, a variable force meaning when it moves from the initial position to final position, the force acting on the object displacing it can be varying, they may not be of same magnitude during this displacement. But still work is done, and therefore, this is called work done by the variable force. The fundamental relationship between the work done, force and the displacement would remain the same, but the idea that the force is a variable force would be implemented or would be used in this formula, and in application we would carefully use the formula. So, let me write the definition for the variable force or the work done by the variable force. So, when a component of a variable force acts on a body, the small displacement is caused, or I can say the small work done, let me just say dW by producing a small displacement. So, the small displacement I am just marking as some dr, small displacement dr is given by the following relation. Now, if you recollect how we defined the constant force or the work done by the constant force, it was similar. We just said when a constant force acts on an object, the small work done producing a small displacement, and we wrote the formula. Here also we are talking about the same, but component of a variable force is acting producing a small displacement by doing a small work dW. That is all the difference, force is different. So, the small work done is equal to F cos theta dr. You would see the formula remains the same, but the point here is this part of it is variable force. So, by variable force what do I mean? F will vary and theta might also vary, because we know that when force acts it can act in different theta. Theta is the angle between the direction of the force and the direction of displacement, and therefore, we can say the variables in this particular case, the variables are F, and also theta can take different values, force can also take different values. So, the component of the force F cos theta can take various values. So, this is the case with small displacement dr corresponding small work done dW. Shall we apply this concept and graphically view what it is, just like the way we did for a constant force? So, let me represent it graphically. So, along the x direction is the displacement, along the y direction is the force, and so any value along the y would give the magnitude of the force. Let me mark the initial position to be Ri and the final position to be Rf. So, in moving from initial position, a small displacement, a small work done involved is dW. So, dW is, so from here to here it is going through a very small displacement dr. What is the corresponding force? The corresponding force here is initially this magnitude, because y axis would give the magnitude of the force. So, Ri, this is the magnitude of the force, but when it took it from Ri to the next position by moving it through dr, now after moving through dr, the magnitude of the force is this much. It is not y, this is different and this is different, and therefore, if you want, you can say this is the area. So, now we know product of two terms, f cos theta into dr, and so this portion is supposed to be the f cos theta portion, f cos theta, and this is your dr. So, f cos theta dr product would give area of the strip. So, you may wonder, here it is not horizontal, how can we call it? And this is what exactly we have explained in second unit, how in integration we make an approximation that this portion, when the strip is very, very thin, then this can be approximated as a horizontal line, and that is the approximation here. Similarly, as it moves from Ri to Rf, it might go through different locations. So, the next force could be this, and the force can reduce as it goes further and further and further, and therefore, so see to that the strips look like this, and therefore, so this is how it goes. So, now also this is the area or the work done, small work done, I can call it dW1, and from here to here this strip, area of this strip could be dW2, and area of the third strip could be dW3. So, it goes on, and therefore, you will be able to sum up all these values. So, you can take this as a summation of all the areas of the strip. So, summation of all the areas of the strip can be replaced by integration. So, that would give the total work done. So, now let me apply the same thing in the equation here. So, this is a small work done. For total work done, in moving from initial position, moving from the initial position Ri to the final position Rf, that is your total work done, is equal to, all that we need to do is integrate between the initial and final this equation f cos theta dr. Now, this is what is the expression for work done by the variable force. Now, carefully see, I have not taken this f cos theta, f could be same let me put, yeah, so same as this. So, f cos theta dr, but I am not taking this f cos theta outside the integration because it is a variable force, and this would be the appropriate way of writing the expression for the variable force. So, total work done by the variable force can be imagined something like this. So, something like this, where from the initial position to the final position, if this is force and x axis is the displacement, I am replacing this by this curve. The area enclosed would give the total work done. Exactly that is represented in the equation way, and this is how the idea of a variable force doing some work is conveyed in the equation form, and when it is a variable force, you identify it as small strips and add the areas to get the total work done, and mathematically the total work done is using integration written like this. So, this would be the expression for work done by a variable force, and we need to carefully apply this situation in conceptual problems.